So we're going to take a look at how populations grow. So definitions first. Population, remember, is when we're looking at the number of species found within a specific area. 3 characteristics we look at, and those are our 3 characteristics. We'll go into each one of them a little bit more in depth. The first one is geographic distribution. This is really the range, where it's located. So when we talk about geographic distribution, we're talking about where does the organism live geographically in specific areas. The other part that goes with that is population density. Population density is the number of individuals within that unit area, as it says on your screen. Really what that means is how thick, how heavy are we actually looking at population within a specific area. Growth rate is the other one, and growth rate is the increase or decrease of population. So growth rate doesn't necessarily mean a positive increase, it can mean a negative decrease. And this is looking at population over time, not just in one setting. There are 3 factors that fit into population growth and that affect the size. And these are kind of silly and they make sense. The number of births, so how many organisms are added to the population. The number of deaths, how many are taken away. And then the other part that adds or subtracts, which is those that immigrate or emigrate from a population. So those that enter, which is immigration, and emigration, which is leaving populations. Okay, so when we look at this, we always talk about the population grows when the birth rate is greater than the death rate. So we talk about population growth occurring when we have both an increase in birth rate and then an increase in death rate, or it actually balances out so that birth rate, there's more being made than there are that are dying. Okay, immigration comes into factor as well. How many organisms come into the area? How many species? Members of that species coming into the population. So those that move into the area is called immigration. So when we talk about immigration, what are the reasons that organisms would come? Well, organisms are always looking for food and they're always looking for mates. So they're looking for resources just like anything else. So immigration is caused by trying to find resources that they need. Emigration is the same thing. Taking from a population, say a population size is too large, and so exit trying to find enough resources, and so they exit to try to find the resources of changing the population, allowing for more resources to occur for the organisms that stay there. Okay, establishing new territories is probably the most common. We can talk a little bit about lion prides and how that works as well. The other thing is if there's a shortage of shortage of food in one area, organisms will exit and try to find an area that's similar to and be like it so that they can actually go get food as well. Now, population growth, really, we talk about the fact that it's considered what's called exponential growth. It only really truly fits at exponential growth in ideal settings when there's unlimited resources. That's not realistic, so therefore we talk about population as an ideal form being an exponential growth. So that means that they could continue to grow at a constant rate no matter what, because there would be unlimited resources. The reality is we don't have unlimited resources. So what we do have is just to see what it would look like at exponential growth. Generally speaking, exponential growth is also called a J curve. Notice that this right here is going to show us very similar to a J shape. Starts out low. Remember that we're talking about populations increasing. You start off with 1 for bacteria, and it splits. So if you're looking at bacteria, remember this is going to have population. This is going to have reproduction that is asexual reproduction, meaning that it's just going to split to create new cells. So we start out with 1 and then doubles from there. Each cell doubles as we go through. So it starts out with small population, and then as the population increases, it all of a sudden gets bigger and bigger and bigger, faster and faster and faster. And that's what you're seeing in here as well. So bacteria, notice that we're looking at in hours, and whereas we're talking about population of elephants, and that is in years. So very different time frames that we're looking at, but the same shape occurs over time. Okay, the other one that's called logistic growth, this is also called an S-shaped curve, which I'll show you. This is more realistic. We're talking about the fact that in nature exponential growth can't happen because we do have limiting resources. So what ends up happening is that as resources become less available, they actually limit the growth of a population. So logistic growth is a population where it is limited or it stops. It slows the growth down. It starts out with exponential and then it goes into a static form. And this is what we're looking at when we talk about this. Logistic population growth is characterized by an S-shaped curve. So notice this is the beginning of your J curve, and then it starts to plateau out and balance. As it plateaus out and balances, As it plateaus and balances, you notice there's this little dashed purple line. There's not really in real life a real dashed purple line, it just kind of exists where we see it. Because what ends up happening is population will get too big, and then we have a dying off of population, and then an increase in population with more resources, and then a dying off, and then an increase, and then a dying off. And notice it goes back and forth and back and forth and back and forth. And that line that kind of fits in the middle of that is called the carrying capacity. And that's basically the amount of organisms that a specific area can hold at one time. So therefore, when we're talking about carrying capacity, we're talking about the limit, kind of the limiting piece that allows for the population for everyone to be happy and stable within their population. Okay, so the definition, which we'll use right here, is the largest number of individuals a population that an environment can handle. When a population reaches its carrying capacity, its growth level balances or levels off. So this makes sense, right? There's only so many resources that exist, and so once we hit that resource, basically we are going to stay static at a plateau. But realistically, in actual reality, is it's not going to ever plateau and be flat. It's always going to fluctuate back and forth and back and forth and back and forth. That line that fits in between is actually going to be what our carrying capacity is. So the average growth rate when you're in carrying capacity, at carrying capacity, is considered 0. Okay, we're going to stop here for this one, and we will actually be done with this part of population. You have a second one to watch after this.